This conference will now be recorded.
All right, this is a video on methods to graph equations in two variables. A solution to an equation that is in two variables is essentially going to be two things, and especially if we're dealing with x and y, it's going to be an ordered pair that makes the equation true. For example, if we had the equation, so let's just write one down. Let's make it an easy one. X plus y equals 5. I could think of lots of different ways that I could make this a true statement. If 1 and 4 were x and y, that would add to 5, even if it was 4 and 1, the opposite way. 0 and 5, we could even have combinations of positives and negatives, say 8 and -3. So there's an infinite list, essentially, of ordered pairs that we could come up with that would work in that specific equation. Now, the set of all such ordered pairs make up the graph of the equation. So when you're graphing, a lot of students don't realize what we're actually trying to accomplish. We're trying to give someone a visual representation of all the true statements that we could create if we had these set of ordered pairs. So it's essentially all the answers to the equation that's possible forever we can represent using the graph. So here are some general methods to find solutions when graphing equations in two variables. These are not the best or the most common methods for each type of equation that we'll encounter. But if you have, no other method to use, these are good to have kind of as general fallbacks. Depending on, and that's kind of where this whole unit of material kind of is leading towards, what type of equations we're dealing with might have different methods that would be more appropriate for graphing. But this, like I said, is a general overview of graphing. So one method is to make a table of values, which we use sometimes called as an XY chart. And another method is to find X and Y intercepts. So I'm just going to go over what the two methods are, and then we're going to kind of integrate them together to graph a few different equations. So to make a table of values, you're going to choose values for the X to plug into the equation. Now, you could choose values for Y as well. It would just swap out what you're solving for. Try to solve for Y. If the value is not a real number, in other words, something like square root of -4, that's an imaginary number. So if you plug something in and you solve it and you don't get a real number, then it would not be a point on the graph, as our XY axis is made up only of real numbers. And then we want to plot at least 3 points if we already know the general shape of the equation by just kind of exposure to different types of equations. And if you have no idea what the shape is, you need to do at least 5 or more. And you need to be careful about how you pick them. And that's kind of where this whole unit is leading, is that we're going to kind of teach you how to pick the points appropriately. So to find X and Y intercepts, you have to realize, remember, X and Y intercepts are on the X-axis if it's an X-intercept, and on the Y-axis if it's a Y-intercept. Those are very specific ordered pairs, and they always have, if it's an X-intercept, the Y counterpart to that is always 0. So that helps us find them. So to find the X-intercept, we replace Y with 0 and solve for X. The answer would be written as an ordered pair, A, 0, where A is what we got when we solved. To find the y-intercept, replace x with 0 this time, so we're getting rid of this x this time, and solve for y. And the answer is then written as 0 for x and whatever number we get for y, so we're calling that b. Now, we're just going to go through some rough sketches of about 4 different types of equations. Some of these you may know already how to graph a different way, and that's fine, but we're going to focus on the methods that are in this section. So the first one here is, this is a linear equation, and the reason I know that is because x is to the first power, y is to the first power, and there's no weird stuff like absolute values. It's just numbers and variables, essentially. So we're going to be looking at this as an XY chart, and I'm going to integrate the idea of intercepts into this. So I know I'm going to plug in 0 for X once and 0 for Y. And then I want at least a couple other points for X. So maybe I'll do, and usually I would do -1 and +1 as long as I can plug those in and get a real number. But because I have this denominator here, I'm actually going to use -3 and +3. You can be smart about how you pick your points, because I know that a 3 would cancel with that 3 in the denominator. So let's work these out. So this would be y equals 5/3 times 0 plus 2. That's just y equals 0 plus 2, or y equals 2. So that is our y-intercept, 0, 2. If I plug in 0 for y, I'm going to be plugging it in and solving for x. So this is the other intercept. So I would subtract over 2. And to get this by itself, we would need to multiply both sides by 3/5. So this one's going to be a fraction. So that comes out as -6/5. So that's going to be the x-intercept is -6/5, comma 0. And when you're plotting that, you can kind of estimate that as a decimal, just so you can get a right idea of where it is. It's -1 1/5. For -3, we're going to plug that in. Be careful with signs always when you plug in. That's going to cancel the 3's out, but then we have a negative times a 5. So that's going to be -5 plus 2. So that comes out as -3. And then the very last one I want to do is 5/3 times 3 plus 2. That comes out to just 5 plus 2, which is 7. So we're going to do a rough sketch. And like I said, I know that this is a linear equation, so I'm expecting my answer to be a straight line. So let's put some tick marks on here. Make sure you try to evenly space them if you're drawing it yourself. You want that to be a nice representation of what the graph actually looks like as well as you can. The best way would be if you had graph paper or if you had a graph on your paper already. Okay, so 0, 2 is right here. No x change, but we go up 2. -1 1/5 is a little bit past -1 on the x-axis. -3, -3 is down here. And +3, +7 is going to be here. So you do notice that these are, oops, that one went away. These are all in a line together. Sorry, excuse me. So the reason we put the arrows on the end of the line is because we're trying to let you realize, remember, that this is an infinite set of solutions. It does go on forever. We could continue coming up with more ordered pairs that work. Okay, when we look at 2, it's a different feature to this equation. There's an x squared, and when there's an x squared and no y squared, the y is still to the first power. This is what we usually call, if that's our highest power, this is a quadratic, and it's going to have a U shape. Now, if you don't know that already, we're going to still get the information we need by plotting enough points. So the first thing we're going to do is we're going to set up our table. We're going to find the intercepts. We're also going to plug in some different values, and let's see, I might pick -1 and +1, and we'll see if we need more than that. We'll just have to see how this goes. So let's plug in 0 for x first. So if we plug in 0 for x, that's 0 squared minus 6 times 0 plus 8. That just ends up being 8. If we plug in 0 for y, this is a different story. This is going to have 2 different intercepts because it's a quadratic equation to solve. If we factor this side, this is x minus 4 and x minus 2, multiplies to +8 but adds to -6. So we actually get 2 different x values. That means we need to write another group here because this is 2 separate x-intercepts. And then let's plug in -1. That would be -1 squared minus 6 times -1 plus 8. That is 1 plus 6 plus 8. That is 15. So see, that's pretty big. So if you didn't already know kind of where you were going to be plotting these points, you might not have a good idea of what to pick. So that's why when I picked 1 and -1, I wasn't really sure if they were going to help me. And we're going to show you why I might still need some more points in just a second. So this is 1 minus 6 plus 8. That is going to be +3. Okay, so let's just plot what we know. And then, like I said, we can determine if we need more values. So 0, 8, 1, 2, 3, 4, 5, 6, 7, 8. And we have 2, 0, and 4, 0. And -1 is up at +15. So this is 9, 10, 11, 12, 13, 14, 15, just way up here. And then we had that 1 was at 3. Now this is where students can sometimes get into trouble because if you don't know this general shape as a parabola, you're kind of like, oh, this looks like a line and maybe I made a mistake here and this point's not really supposed to be there. So that's why it's good to know the general shape of some of these equations. Now, I don't know what's happening in between here, so I think I want to plot 3. And I definitely have tons of points to the left of 2. I have nothing really to the right of this, so I'm going to plot 5 as well. It never hurts to check more points if you're not sure. So 3 squared minus 6 times 3 plus 8. That's 9 minus 18 plus 8. That is negative 9 plus 8. That is negative 1. And 5 squared minus 6 times 5 plus 8 is 25 minus 30 plus 8. That's negative 5 plus 8. So now we're seeing a pattern. This also comes out as 3. And that's something you see in those quadratics, is that there's symmetry. And so 3 was at negative 1. Now, the thing is, the assumption is being made here that we know for sure that that's the lowest point of this U-shaped graph. We would have to find the vertex to prove that. But here's just a nice hint. If there is symmetry in a quadratic, then if these two x-intercepts are here, then the middle had to be halfway between them. So that's going to be that lowest point. We will have a technical method for finding that vertex exactly in a future section, but we wanted to kind of point that out now that I'm kind of not 100% sure just by a table of values if I actually have the vertex or not. So let's look at this one. This is y equals x cubed plus 8. So we're going to look at doing a table here. We're going to try to find the x and y intercepts by plugging in our zeros again. And maybe we'll do negative 1 and 1. We'll see if that helps us or not. Oops, I wanted that thinner. All right, so let's plug in 0. So that would be 0 for x would just give me 8. 0 for the y, though, I have to solve this. That means subtract 8. And then I'm taking a cubed root here. Now, when you take a cubed root, you do not write plus or minus. If we were taking a square root, we would have to write plus or minus. A cubed root is going to have a singular answer, so it's going to be negative 2. If we plug in negative 1 cubed, that is negative 1 plus 8, because negatives stay negative when you cube them, so that's 7. If we plug in 1, that's going to be 9. So let's just plot what this is and kind of see what we've got. So 0, 8. We have negative 2, 0. We have negative 1, 7. And we have 1, 9. Now I'm probably going to plot 2 as well just to get an idea of where that's going to be. So that would be 2 cubed plus 8. That's 8 plus 8. That's 16. So 10, 11, 12, 13, 14, 15, 16. And that would be for positive 2. Now, that kind of gives you a good idea of what the shape is here. It's not a straight line. It's actually, it looks like a parabola that's kind of been bent. One way is up and the other way is down. And that has to do with when you cube something, the negatives will stay negative and the positives will stay positive. Whereas when we square something, negatives and positive both go positive. So this is what we call the shape of something that's raised to the third power. It's a cubic function. And we'll define that later, but this is kind of the picture without knowing that ahead of time. And then our very last one, again, this is all just kind of exploring graphing by table of values, is a square root. So this is where we get into trouble and why I had to make a notation in the notes about you have to make sure that the numbers you're plugging in actually exist on the number line. So if we plug in, let's see, 0 to try to find the y-intercept. So if you plug in 0 here, this is square root of 0 minus 2. That is square root of negative 2. That is imaginary, which means it's not on this graph. So there is no y-intercept. So it's good to know ahead of time what values are you allowed to plug in. So with a square root, notice this is specifically for square roots and even roots. You can't have a negative underneath because that would make the answer imaginary, and that's not going to be on the real number line. So we have to force the inside of this to stay not negative, which means greater than or equal to 0. So that means that I can only plug in values that are greater than or equal to 2 in this scenario. So I'm going to go ahead and make a chart with those values. So if we plug in 2, 2 minus 2, square root of that is 0, so that's just going to be 0. So there is an x-intercept. If we plug in 3, that's going to be square root of 1, which is just 1. If we plug in 4, that's going to be square root of 2, which is approximately 1.4. And if we plug in 5, that's going to be square root of 3, which is approximately 1.7 if you use your calculator. And if we plug in 6, just to get one more, that's going to be square root of 4, which is 2. Okay, so when we plot this one, notice we did not cross the y-axis at all. So we have 2, 0, we have 3, 1, we have 4, 1.4, 5, 1.7, and we have 6 is at 2. This is getting slowly, slowly, slowly bigger at a curve. And it actually looks like a half of a parabola that has been then turned on its side. And there is a reason for that, and that's discussed kind of later on. But this is just, discovering what can we plug in and doing the table of values based on what makes sense for the number line. So I hope you guys found this video informative. And like I said, we don't always use the table of values and the x and y intercepts as our number one go-to way to actually graph, but it is a great fallback method if you do forget something else, and you can actually still come up with a successful graph. So I hope everyone has a wonderful time learning about all the equations that we're going to learn about this unit and how to graph them a little bit more sophisticated.